MPLS layer 3 VPN. Router 1 and router 2 are blank. The other routers has got some configuration like IP address, OSPF and MPLS. About router 5 and 6, which is blue customer, and 7 and 8, which is yellow customer, I'm not sure whether it is configured or not. If it is not configured, we have to configure. If it is configured already, all that it will be there is only the IP address and EBGP peering. That's all. We don't run MPLS on the customer side. On R2, I'm inside F00 now, which is facing the core network of ISP. The IP address I want to give is 10.24.0.2. 255.25.0.0. IP OSPF1 area 0. I'm expecting a neighbor now. Interface loopback 0. IP address 2.2.2.2. 255.25.25.25. IP OSPF1. That area, sorry, the OSPF neighborship which has come, what it tells me is R4 is configured already. Now, what next I want to do is I want to clear IP OSPF process once, because when the OSPF process started, there was no loopback interface. So I fear that it might have taken the physical interface address as the router ID. Now let's go to router 4 to verify whether the neighbor router 2 is seen as, you see, just taken 1024 physical. So let's go and change the router ID. Router OSPF1 router ID is 2. And then I say clear IP OSPF process. Then as a result, I'm expecting on R4 a new neighbor. Show IP OSPF neighbor. Okay, you see it is in extract state. This is going down. This is going to die. 20, 18, 17. The router ID is very important. If the router ID of OSPF and BGP and MPLS, if all three router ID is not same, then there will be a problem in the layer 1 and layer 2. So not in layer 1, layer 2. The data plane will become a problem. Fine. So now the OSPF router ID of router 2 is 2222. And now if I enable MPLS on router 2, MPLS will also pick the same router ID. MPLS IP interface F00 MPLS IP. Boom. And if you go back to router 4, you should see the router ID of LDP is also 222. Good. Next is I'm going to router 1 to do same OSPF and MPLS. Let me first finish the loopback so that you don't need to give the router ID manually in OSPF. I'm expecting OSPF before that. Okay, it is done. MPLS IP interface F00, MPLS IP. Now I'm going to trace the route to reach 2222. I'm expecting some label. Good. MPLS is done, OSPF is done. Listen, you got OSPF, you got MPLS. It's time to configure IBGP between R1 and R2. Why IBGP? Why I need IBGP between R1 and R2? Because I want to negotiate tunnel which can transport a labeled packet. For that, the service, the option is available in BGP because BGP is a TCP based protocol. It can use the community value to carry those route targets and can carry the labels as an extended community attribute. That's why I need BGP. So BGP between R1 and R2 using loopback router BGP 100. Neighbor is 2222, remote AS is 100. Neighbor 2.2.2.2, update source loopback 0. Just IBGP I'm doing first, later we'll come and configure VPN. I'm back to router 2 and I'm saying router BGP 100. Neighbor is 101, remote is 100, neighbor is update source loopback 0. All right, I'm expecting peering between, okay, the peering has come. Now I don't know. Next is what I'm going to do is I'm going to configure VPN. It's very simple. Address family VPN v4 unicast. See, without forming IBGP neighbor, you don't go inside this. Why? Here you are going to say, I got a neighbor already. Activate VPN for that neighbor. Hope you understand. You need to have neighbor already. That's why I said first you finish your IBGP. Now I'm going to router 2. Here I'll say address family VPN v4 unicast neighbor under activate. Now you will see second BGP session will come up. First session with 2222 is a normal IBGP. The second session which is going to come with 2222 is a VPN session. It has come, you see, second session is up. This is VPN. Let us verify this. Show BGP VPN v4 unicast summary. Unicast for all VRF, all summary. You see here 2222 is neighbor for 22 seconds. For 32 seconds. This is the command to see the VPN neighborship, the second session. If you want to simply see IBGP neighbor, show IPBGP summary. That is different. See, this is there for more than 2 minutes. IBGP configured earlier, right? So it shows 2 minutes, 5 seconds. Whereas the VPN is just configured like 32 seconds. Maybe now 1 minute. But the normal BGP is 2 minutes. So first you configure what? IPGP. Second, VPN v4. So far good. Anyone has got any question?
Yes. So the IBGP peering. So this address family command, it uses VPN v4. Should we think of this as like how IPv4 is and how IPv6 is, which is a different address way to address something?
Yeah.
Should VPN v4 be considered the same way, like it's a different address family like IPv4 and IPv6?
Yeah.
Is that okay?
That's right.
I see. Okay. And can these different address families intermingle with each other, like talk to each other? In a sense, is like it's a different address anyways, right? This becomes a VPN v4 address, or at least whatever the route exchange will happen between these two neighbors, it will be of address family VPN v4.
Yeah.
Is that so? So so now if there is a IPv4 route on R1 or R2, will they be able to like talk to the VPN v4 route on the same router?
No.
Does that make sense? No.
No. VPN is only for VRF. The normal routing table and the routes that is there in the default routing table will not get into this VPN.
Okay.
The routing table on R1, which is having the routes of service provider network, that cannot enter into VPN because VPN is only for those updates that are given by a VRF routing table. So those routes that are advertised from the customer into the VRF table, for only those networks this tunnel is going to work.
I see.
So your question is,
okay.
will the default routing table use this tunnel? That was your question.
Yes.
Answer is no.
Okay. So this is how the routes are separated then, like from the global routing table versus the VRF or VPN.
Yeah.
Okay. Because it uses different address family, and so they are a different class of addresses.
Yes.
And a different routing domain or whatever. Okay, I see.
Sir?
Yes, sir.
So router 1, router 2, the link, this one is lease line, huh?
It can be any line. It can be a lease line or anything. You see, between router 1 and router 2, it is only the service provider core. If they why they will have a lease line? Okay, for a customer, for a blue customer, it's an MPLS connection. It's not a lease line. It's an MPLS connection. That's the type, MPLS.
So what is the VRF name you configured, sir, for this?
So far, we have not configured anything.
Oh.
I deleted everything and I started a new router. You remember router 1 and 2?
Yeah.
So far, we have created a VPN which is going to be used by a VRF that you will be configuring after now.
Oh, okay. Yeah.
So are we allowed to configure multiple VPN tunnels?
No. This is the only tunnel which is going to be used by all the customers.
Okay.
You are not going to configure multiple tunnels. No, only one VPN. Only one VPN. Only one VPN, but the encapsulation is going to be different because the route targets are different. That is going to differentiate one customer from the other. But VPN is only one.
Okay.
Based on the route target, import and export, what to download from VPN, what should not be downloaded is determined. So there is no need for multiple VPNs. There is no need for multiple VPNs. Just one is enough.
Okay.
All right.
Sir,
Yes,
sir,
sir.
one question, sir.
Yes.
Sir, normal tunnel, that is show IPPGP summary, which the neighborship came up, and the VPN v4 neighborship. Why we need, sir, the normal one?
See, What is the command you used under
Because anyway, my neighborship will be VPN v4 address.
What is the command you used to configure VPN?
Address family,
Neighbor.
and then neighbor.
Okay,
Activate.
neighbor. Activate. What did you say? Did you say neighbor remote AS 100? Tell me. Did you configure
No.
IBGP there? No. You are just activating
No.
VPN for the existing neighbor. So you should have an existing neighbor. That's why you formed IBGP first. You understood?
So whenever I will configure, so we have to create one neighborship, then we'll get into the address family and just to activate that.
Yeah. Under the address family VPN v4, you don't have any command to say neighbor 2222 remote AS 100. That command is not available.
Sir, sorry, I'm just requesting one more time, sir. Can we bring up one more neighborship, or can we just show me one more time, sir?
I'm not getting you. You want me to add another PE router, or you want to redo the same thing what I did?
Maybe add the new another router and send one more time, sir.
Okay, you want me to add another router? Okay, no problem. We can do it.
Sorry, sir.
No problem. Yeah, Mr. Sheikh Ji.
சார் சார் இப்போ வந்து R1 R2 மட்டும் தான் சார் நம்ம டன்னல் வந்து கிரியேட் பண்ணிருக்கோம். ஆனா வந்து இப்போ ஒரு கஸ்டமர் வந்து ஒரு 10 கஸ்டமர் இருந்தாங்கன்னா போத் சைடும் அப்பனா ஒரு டன்னல் மட்டும் போதுமா சார் சென்டர்?
If all the 10 customers are connected to only R1 and R2, this one tunnel is more than enough. If you have another router in which some branch offices are connected, meaning if you have more than 2 provider edge router, even then the tunnel is going to be only one, but the tunnel endpoints will be 3 because you got 3 provider edge routers. Tunnel is only one. Whether you have 2 provider edge or 3 provider edge or 10 provider edge, there's going to be only one MBPGP tunnel layer, MBP VPN v4 tunnel, only one. But for every customer, there is going to be different route distinguisher and route target. That will take care of separating one customer route from the other. So if you think that there may be need for more tunnels, I tell you no. Only one tunnel. Did I answer you, Sheikh?
Yes, sir.
Now what I'm going to do is I'm going to add another provider edge router in this topology so that we can see from 0 level another provider edge. Okay, no problem. Where I'm going to connect is I'm going to connect right here. I'll bring this one down. Boom, boom. And I'll delete this one so that only yellow is connected there. I'm going to have blue on different PE router. What do you say?
Sir, one more thing I'm asking, sir. Between the R4, R3 and R1, we are running OSPF. We can even also run, sir, BGP, right, sir?
What do you say?
Between R4, R3 and R1, we are running here OSPF.
Yes.
So we can also run BGP there.
Why?
We can't.
Why you want to run BGP? See, first of all, you are putting tunnel between R1 and R2 because you do not want every router inside the service provider network to learn the customer's route. If you run BGP on every router, then whatever the customer advertises will not only go to R1, it will also go to R2, R4. Not good. And also you will have a IBGP split horizon issue, then you need to go with confederation, route reflector, all this fully mesh, all the story will come into picture. In order to avoid all that, we have VPN. Why you again go back to the old history?
Understood.
Sir?
Yes, sir.
But technically, sir, we can run also.
Answer is
Sir,
Because we need
R3,
for the
answer
reachability.
is yes, sir. Answer is yes, sir. But we don't do that, sir. Can that be a solution? Yeah, it can be a solution. But is it not? Is it an acceptable solution in the industry? No.
What recommendation? Okay.
Not recommended. Correctly
sir,
said.
sir, I forgot, sir. R3, R4 is now OSPF and MPLS running. Okay.
Yes, sir. R3 and R4 runs OSPF and MPLS. That's right, sir. All right, I'm going to OS router 4 and I'm going to add interface 3G3/0 and IP address 10.49. Oh, not now, not now, not now. Yes, sorry, it's router 4. I have to do it. Interface G0/3/0. No shut IP address 10.49.0.4. 255.255.0.0.
Sir, 4.
It's okay. 044
Okay.
IP OSPF 1 area 0. All right. MPLS should be running there. Interface G3/0. MPLS IP. Now R9 is totally new. Looks like the router is ready. Let us go. You see, interface loopback 0 IP address 9.9.9.9 255.255.255. Oh, yeah, correct. IP OSPF 1 it is 0. Interface G3/0 no shut IP address 10.49.0.9 255.255.0.0 IP OSPF 1 alias 0. And then what I need to do is MPLS IP. I'm expecting now OSPF neighbor, it has come. Sorry. Next I'm expecting MPLS neighbor. Okay, it has come. Now I'm going to form IBGP. Focus.
Yes.
Router BGP 100, neighbor is 1.1.1.1, remote AS is 100. Neighbor 1.1.1.1, update source loopback 0. Neighbor 2.2.2.2, remote AS 100. Neighbor 2.2.2.2, update source loopback 0. Alright, then I'll go under address family VPN v4 unicast neighbor 1.1.1.1 activate neighbor 2.2.2.2 activate. That's all. Finish. Now I'll go to router 2 and say you got another neighbor 9.9.9.9 remote. Someone is having some background tung noise. Mute your mic, please. Neighbor 9.9.9.9 update source loopback 0 address family VPN v4 unicast neighbor 9.9.9.9 activate. Likewise, I have to go to router 1 router BGP 100, neighbor, new neighbor, address family, VPN v4, neighbor, new neighbor, activate. Now you're going to see two BGP sessions under VPN. Show VPN v4, show BGP VPN v4 unicast all VRF summary. Okay, so we got two neighbors, means this tunnel has got two endpoints. The tunnel that is starting from R1 has got two endpoints. One is 2222, another one is 9999. Likewise, if I go now to router 9, show IPBGP, not 9 IAP, show BGP VPN v4. Two VPNs. One with router 1, another one with router 2. Means not two VPN, one VPN, two endpoints of the VPN. Likewise on router 2. Show BGP VPN v4 unicast all summary. Yep. Okay. So we got VPN. Now we have to create VRFs. On router 1 I have to create two VRFs because I got two different customers. Whereas on router 9 and 2 I'll configure only one VRF, one for blue, another for router 2. Sorry, another for yellow. Another for yellow. But before I start VRF, I would like to just go and check R5, R7, R6 and R8 whether it is ready. Otherwise, I'll finish VRF by the time the time will get over. And then by the time you go to R5, R7, R6, R8, nothing will come. And then we will do it again tomorrow. That won't be nice. So let us first bring the customer up, then we'll come to VRF. Still, someone has not mute the mic. You're getting continuously message from your girlfriend. You have to mute your mic.
No, sir, I mean, I'll get call also. Anyway.
Oh, it's you only. Okay. Of course, you are an unmarried guy. You should be getting a lot of message. Okay, I'm on R5. Show IPBGP. Good. This is already ready. Likewise, R6, 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 R6. Show IPBGP. This is not ready. There is no neighbor. Show run section router BGP. I have configured a neighbor. I think that the interface has changed. Show IP interface brief. Okay, this is 3/0, but what I'm correct. 26/26/06 3/0. 26/26/26/2. Okay, anyway, this is going to be 9 because on router 9 is what we are connecting R6. Earlier it was connected to 2. So anyhow, I'll remove this BGP and put it back. No router BGP 20. Router BGP 20 neighbor is 26/26/26/9. Remote AS is 100. And then what I'll do, I'll advertise the network. 6.6.6.6. Okay, so we got the neighbor 26, 26, 26, 9 now. Instead of 2, I made it as 9. Let's go to router 8. Show IPBGP summary. Good. Okay, now what is next is we are going to create VRF. I need your full attention. I'm going to finish this today. Maybe tomorrow we'll do only verifications. We are going to create VRF on router 1. I'm going to say VRF blue. Route distinguisher, I'll give 1:1. Route target for both import and export, I want to give 1:1. See, I'm just showing you that route target and route distinguisher value can be also same. If it is different also okay, if it is same also okay. And I'm not mentioning import or export. If you don't mention, it is for both import and export. Okay, now next is another VRF, yellow. Route distinguisher is going to be 2:2. Route target, I'm going to say maybe 22:22. When I don't say import and export, what does it mean? It means both. Import and export is 20. Okay. Now on router 8, what I'm going to do is on router 9, what I'm going to do is router 9 first. On router 9, what I'm going to do is I'm going to create a VRF called, see, I'm giving different name. That is simply to say that name need not to match. What is this? Why are you jumping? I'm going to say blue. It's blue. Wait, blue. I left the E there, okay? And route distinguisher can be any number. I'm giving 11 here. But route target should match. So I'm keeping route target 1:1 in left hand side as well as in router 9. Okay, let me keep it here only so that it will be easy for us to see. And router 2, I'm going to say yellow. 2:2, 22, it's okay. Yep, I'm going to have the same route distinguisher, but route distinguisher can be different. Okay, I'm going to say 12:12. Fine. See, three things you should have in VRF. One is the route distinguisher, another one is the route target, and the third one is the interface. You should put the interface in the VRF. After putting the interface in the VRF, you will assign IP address to the VRF. Will the story end there? No. You also need to have a EBGP via VRF. And then only the story will end. So let's do it now one by one. I'm going to router 1 first. On router 1, router OSPF, router, I'm sorry, not OSPF, what am I doing? IPVRF, give a name. What's the name we decided? Blue. RD 1:1. Route target 1:1. Next, IPVRF yellow RD 2:2. Route target 22 colon 22. Next is what? The interface. See, interface G3/0. I need to put it to which VRF? Blue or yellow? No, Arindram. Someone else. Blue or yellow?
Blue.
Okay. I'm going under interface G3/0. No shit. IPVRF forwarding blue. Same spelling you should use. And then give the IP address. Don't give IP address before assigning to a VRF. When you don't assign to a VRF, it will be a member of default routing table. Now, after assigning to VRF blue routing table, only then you have to give IP address. Otherwise, the IP address will get removed. After giving IP address, if you assign to a VRF, the IP address will get removed because when you assigned IP address, it was a part of global routing table. Now, IP address 15, 15, 15, 1, 255, 255, 255, 0. And next is interface G4/0. No shit, IP VRF hello. IP, what is this? You are doing wrong. Not IP VRF. Focus, J. IP VRF forwarding hello. Right? Still I'm inside the interface. I put the IP address 17, 17, 17, 1. 255, 255, 255. Correct. Done. Now we have assigned the interface to the VRF verification. See, show IP VRF. You should see the interfaces assigned properly, correctly. You also see the route distinguisher. If you wish to see route target, then what you need to do is you need to type this command detail. Then you can see even the route targets for all the VRFs. Okay, router 1 is over. Likewise, router 9. Where are you, 9? Where have you gone? Okay, you are here. IP VRF. I said I'll give different name now, so BLU. RD is 11:11. This is also different from the router 1 configuration. RT is 1:1. This is correct. IP VRF LO. RD is 12:12. Route target 22:22. Next is we are going to allocate the interface. Jay, you are doing wrong. Can someone say what mistake I did?
No need for
There is
yellow.
no need for yellow.
Yeah.
But if you have also nothing wrong, but I don't want unnecessarily, the routing table will get created, the routes will be maintained. Okay, I removed it. Next. Go under interface G5/0. Show IP VRF. I can see here BLU has got the interface member. Next is what? Show IP VRF detail. You should see route target also. Okay. I need to go to route 2 and finish this. IP VRF LO. RD is 12:12.
So IPVRF forwarding.
Yes, sir. That's not right. IP VRF forwarding is under the interface. I'm creating the VRF now. Route target 22:22. Confusion because we are doing too many things in short time. That's the problem. You listen to this video after this class when the video is available. You will be out of confusion. Now, I'm going to interface G4/0. No shit. IP here only you will say IPVRF forwarding hello, and then we say IP address 28 28 28 2. Okay, so we have assigned the interfaces show IPVRF. Very good. Now what is next is the BGP. See the last step. This is the last step. I'm in R2. Listen carefully. Router BGP 100. You need to go on the address family, not VPN v4, IPv4. VRF hello. After going under this only, you should say neighbor because you are not forming neighbor with the default routing table. You are forming neighbor with the VRF routing table. So you need to go under the address family IPv4 VRF hello, and then you say neighbor 28.28.28.8. Remote AS of hello is 40. That's it. And you will see neighbor coming up. Likewise, I need to go to, see, you got VR, and using VRF, you got the neighbor. Show IP route VRF hello. You can see the route coming from the customer. Okay, I'm going to now router 9 to finish VRF. Sorry, BGP. Router BGP 100, address family IPv4 VRF blue. Is the spelling right? Yes, I know. It is correct. Yep, blue. Neighbor is 26, 26, 26 dot 6. Remote AS is 20, and you will see a neighbor coming up. Likewise, I need to go to router 1, router BGP 100, address family IPv4, unicast for VRF. Yeah, okay, unicast is option. VRF for what? Blue, right spelling here. And then I say neighbor is 15, 15, 15, 1, sorry, 5. Remote AS is 10. Likewise, I have another neighbor, address family yellow, VRF yellow. Neighbor is 17, 17. The unicast is optional. Dot 7. Remote option is a remote AS is what? What's the remote AS of yellow in the left? 30. And now you will see neighbor. Now I'm telling you, this blue and blue can ping and yellow can ping. Okay, I want to show you. See, if you see the VPN now, show BGP, VPN v4 unicast. You can see VPN v4 unicast all, means all VRF. You can see the routes coming from router 5 and 6, which is blue in the VPN. You can also see 7 and 8, which is coming from yellow. All right, now what I'm going to do is I'm going to go to router 5. Router 5, where are you here? Show IP route. You can see the route coming from the remote office 6.6.6.6. You don't receive 88888 or 777 here. Trace route 6.6.6.6 with a source 55555. You will see the packet goes to router 6. You see? And there are two labels. This 23 is the VPN label, and this 21 and 17 is the local transport label inside the core. If you try pinging 888, you will not be able to reach because you don't have a route, because it is from other customer. From 7, you may try pinging 888, or you can go to router 8 to ping 7. let us go to router 8 and trace route 7.7.7.7 source. It goes to router 7. So we have finished MPLS layer 3 VPN.